So just to give you a level of perspective, where are we in terms of syllabus? So we finished chapter 16. We're now on chapter 17. Today, we're going to do rotation about fixed axis. And then hopefully by the end of this week, we could finish general plane motion. Next week will be chapter 18, work and energy. And work and energy is the last chapter that we're going to do. Okay. We only have, if you look at in terms of scheduling, just to keep you in perspective, the last lecture will occur on December the 1st. December 4th and 5th is just revision. Are we clear? Okay, so we will test you up to any topics up to December the 1st. Are we clear? Okay. So if you look at the final is worth how many percent? 50%. But the number of topics is also what? Less now. Are we clear? So you should do well. Okay. Term test correction is tomorrow. The question is exactly the same. Okay. So you have seen your answers, how you did. I will advise you to try to figure out now where you've gone wrong. Okay. Or ask some of your friends, but do not ask me. Okay. It's against the rules. Okay. You have to find out from your friends where you've gone wrong. You can talk about it and then come and write. Okay. Any other questions from anyone? Anyone? Are you okay? Right. So today we are going to look into rotation. About a fixed axis. So this diagram, can you all access this diagram on Avenue to Learn? Can you check, please? Yep, thank you. Okay, so if you look at this diagram over here, right, the rotation is about a fixed axis. So over here, this region or this point O over here, this is the fixed axis. Okay, and what we have both omega and we have both alpha, and then all the F's are the applied force. And over here are the applied moments. And what you see over here is a term we call rigid what? Body. Okay. So what we realize is point G is the center of gravity. And it moves on in a circular path of radius RG. Okay. So the thing to take note is the acceleration of point G has two components. And you guys have seen this before. Okay. The first component, which is the tangential acceleration. And is what we denote as AGT. And we know that AGT, based on the topic that we done before the term test, is equal to RG alpha, where alpha is the angular acceleration. And then we have another component, which is the normal acceleration. So this is equal to AGN is equal to omega squared R. Okay, RG, where omega is the angular velocity. So just quickly recall, if we want to find acceleration at point A is equal to acceleration at point B plus by alpha cross R A over B minus by omega squared bracket R A over B. This is what we call our what? Based on the formula, this is our tangential acceleration. And over here, this is our normal acceleration. And just to quickly take note, if this is the center of rotation O, okay, and this is the curved path, this is our circular path, sorry, right? And if we have a point over here, and noting that omega, and let me draw elsewhere, noting that in this rigid body, omega and alpha are in this direction. When that is the case, we know that over here now, will be our AT, and pointing towards the center, this will be our AN. Let me switch this O a bit because it has to be 90 degrees. Okay. So this point over here, we can call it as our point G. Okay, this point over here, we can call it for point G. Then when this is the case, we need to satisfy three sets of equation. And immediately when you have something like that, you will label this as your N axis, and this will be your tangential. Okay. So summation of forces in the N axis is equal. So for this case, is going towards this direction. That is your positive direction. So this will be M A G N. Okay. And we know that AGN is omega squared R. So this will be equal to M R G omega squared. Okay. And then in terms of T, this is positive. And I want you to take note that what is positive is dependent on your transformation. Okay. So summation about forces in the tangential direction is equal to M A G T. And this, I just have written down, this is equal to M R G alpha. Okay. And then summation about moment at the center of gravity is equal to IG alpha, where IG is our mass moment of inertia. Okay. Now, if we want to find, I'll let you guys finish copying first. Are we okay? Okay, so I'm going to take another diagram, and I want you to refer to this diagram also. So now for this case, okay, for this case now, right, based on this configuration that what you see earlier, the example before, right, the example before, we take mass moment of inertia about point where? Point G. Okay. Now, if we were to take the mass moment of inertia from point O, okay, so how does it look like now? Is we are going to take the mass or the moment of inertia or the moment from point O. Okay, and point O over here is the fixed axis of rotation. Can you all see my handwriting, yes or no? Or is it difficult? Are you okay? Okay. Okay, let me zoom in a bit. Okay. So when that's the case, right, we can take, so we're going to take moment about point O here now. Okay. And then we are going to write down anything that's anti-clockwise. That mentioned about moment from point O is equal to Ig alpha, right, plus by M AGT, okay, tangential, multiplied by the distance RG. Okay. Now AGN will not induce any what moment at all. Okay, so that's equal to what? 0. So when we rewrite this slightly, you have Ig alpha plus by M, and this will be equal to RG AGT is equal to alpha RG multiplied by RG. So this will be equal to Ig plus by M RG squared, and the whole thing multiplied by alpha. So the only thing that changed, if you want to consider the rotational axis, is this equation over here. I want you to take note of that. Right, I think enough of the theory. If I keep on talking about theory, I'll fall to sleep. Let's look at one interesting example. Okay. So we have a pendulum. We have a pendulum. It consists of a 10-kilogram uniform slender rod. So this will be our, did we do this? No. No, right? This is the first time. Okay. So this is our slender rod. And this is worth 10 kilogram. And a rod and a spear. So this is our spear. Our spear is 15 kilogram. Okay. Given that the pendulum is subjected to a torque of 50 Newton meter. So this is a torque that we see. I don't know why when they call torque, they call it moment. I'm pretty pissed off now.